Okay, guys, we are ready to start a new unit, and we are going to be looking at what we call quadratics. And if you remember back in Unit 7, the quadratics are ones that have you have the two here, you have the squared, okay? So the degree is a squared. So it will look like this. This is the standard form of quadratic. We have y, or this could be f of x. A lot of times it's the function, so y or f of x equals a x squared. So your leading term has a square in it, plus bx plus c, where a, b, and c are all integers. A, b, and c integers. They could be fractions also. They could be rational numbers. So I probably should put rational numbers, but we can clear the fraction to make it easier to work. So when you graph it, now hopefully you did a thing on Desmos to where it was a basketball and they were shooting the basketball. And then you saw that if you try to graph a linear equation, that basketball would never arch to make that to make that basket. But you were using that Desmos program to kind of guess or kind of see where the ball would land in the basket. So you were making a shape like this. This is called, or now in the basketball, it'll do this. You can also have one that looks like this. Okay, these are called parabolas. So parabola. It makes a U shape and it's called a parabola. I have to say that slow. Parabola. Okay, we're going to identify the A, B, and C term in a quadratic equation. Well, if you see something like this with the x squared, notice this would be like 0x plus 0 if you think about it in standard form. Well, we're going to identify the A term. The A term is your first one with the x squared. And if it's not in order, if it's not written properly, you've got to be careful. The x squared is the one that has the A term. Not always the first, because if they put a bx first, you got to rearrange it. Then 0 and 0. So A is 5, B is 0, C is 0. All we're doing is identifying the terms and the coefficients in each one, so we know what we're talking about when we talk about the A term, the B term, the C term. Okay, so notice it's a negative 2x squared. We don't have as x, so that's like 0x, and then we have just a 7, the constant. So A is negative 2, B is 0, C is 7. Here, now there's nothing in front of it, so that means it's a 1. This one, this x, that's a negative 1. That b term is a negative 1, and c is a negative 3. So we're just practicing identifying the a, b, and c term, because that's going to come up quite a bit throughout this whole unit. Okay, now types of parabolas. So we have ones that open upward, and we have ones that open downward. Well, if you notice, if it says a is greater than 0, that means your a term, that one's greater than 0, that one's greater than 0. Here's one that's less than 0, so this is greater than, and this is less than. And if it's less than 0, it's like a negative 2, that a term, it's going to turn it upside down. If it's greater than 0, it's going to turn it opens upward, okay? Now, if the a is positive, so greater than 0, so anything greater than 0, it can be 0.00001 if you want. The parabola opens up like a smile, okay? Like a smile, so that's what they're trying to do here. If the a is negative, then it opens down like a frown. Down like a frown. So that's what that symbol is. Okay, vertex. Now, the vertex, when you were watching the basketball one, if you weren't, but just think about when you shoot baskets with the basketball, you're throwing, the person, my beautiful stick figure, is throwing the basketball up, and then at some point, it changes direction. Okay, and it goes into the basket. Of course, I will always make the basket. Just teasing, I'm not. Oh, that looks like another person, sorry. But at one point, you throw the basketball up, and at some point, it stops, and it changes directions. This is the turning point. This is what's called the vertex. So the vertex is the turning point. That's where it turns and changes directions. It's like when you're diving in a water, and this is an example. You're diving into a pool, you're turning because you need to come back up for air. That would be your vertex, your turning point there. That would be your vertex. This would be your vertex. Okay, where the vertex is the lowest point, this one, the lowest point, and that's your minimum. minimum. And then, of course, then that's your maximum. So we're just talking about terminology right now of all these parabolas. Now, axis of symmetry. We're going to shortcut that to OAS. So when you see that, OAS, that is your axis of symmetry. Now think about what symmetry is. If you're symmetrical, as a person's symmetrical, then it would split the person right down the middle, okay? If that was symmetrical. The letter M, capital M, that's symmetrical. So axis of symmetry is where it looks the same on both. So the axis of symmetry is going through that vertex point and making it the same on both sides, okay? So the vertical line of symmetry passes through the vertex. So it passes through the vertex, and we're going to work on this formula. Now, to find where it passes through that vertex, that ordered pair, we use this formula. We use A, the opposite of B, over 2A. Oh, did I say A? I meant X if I said A. I apologize. So X equals the opposite of B over 2A. Now, the B and the A, that comes from our numbers from up here. So we're going to do some work here in a second to find that. Now, if you find X, after you find X, think about what you want to do if you have this equation to find Y. Well, if you know what X is, you just plug it in and solve for Y then. So to find Y, so your X is going to be this. To find Y, you're going to plug in the AOS, the axis of symmetry, this formula here, when you find X, for X into the equation, and then solve for Y. So we're going to do some work, but just to understand what this means, we'll do some work with this. Once you know what X is, you can plug it back in the equation to find Y. That means what is X? Use the equation and you'll find how far you have to go up for Y, okay? So the y-intercept. Now think about the y-intercept. Remember when it was a linear equation? The y-intercept crosses the y-axis. Okay, so the y-intercept where it crosses the y-axis. Now, in order to cross the y-axis, the x value, this is y-axis, the x value must be what again? Must be 0. Okay, the x value, which, think about our equation, the x itself is not 0, so I apologize for this. The c here, the c term, when x is 0, sorry, it is. When x is 0, everything's gone except for the c term. So let's change that. I don't want you to get that confused. The c value is what's in standard form, meaning when x is 0, so the ordered pair will be 0, like 0, 7, 0, negative 3. Because when x is 0, these terms cancel, and then your c term here is going to be your x or your y-intercept. I know this might seem like, what the heck? Usually we would do a lot of investigation and you would be finding all this out by using Desmos and practicing and doing all this. Okay, so let's look at the x-intercepts. What are the x-intercepts? So this picture really helps us. The x-intercepts are when they cross the x-axis, okay, where it crosses the x-axis. And in order to cross the x-axis, the y values must be 0. So these are called solutions, roots, or zeros. So when it crosses the x-axis, that means the y value, the y equals 0. Now, you'll hear us say solutions, roots, or zeros. We need to know where they're crossing the x-axis. When is y 0? Now, domain and range. Domain, again, remember domain. Domain is your x values. So that's all your x values. Your range are your y values. Your domain is like how far down. Usually the x values have a minimum or a maximum. And then the y values usually are like all real numbers because they'll continue going all over or up and down. Okay, now we're going to practice. So we're going to look at all this information and we're going to add, we noticed we left off vertex. So we're going to add that to each of these also. So here's your equation. Give the requested information, then sketch each parabola, then check your sketch with the graphing calculator. You don't have this, so you can use Desmos if you want to check it to see if what we sketch looks just like what we can do in Desmos. So we have f of x, which that means that's the y term. F of x equals negative 3x plus 6x plus 2. Now, in order to find these, your axis of symmetry, your y-intercept, your vertex, we need to know the a, b, and c term. It's in order. First of all, always make sure that it's written in order because sometimes they try to trick us. So this is negative 3. That's 6. That's 2. So that's a negative, that's a positive, that's a positive. I always double check that. Now, does it open up or down? Again, that's your a term. If it is less than 0, which the a term is, it opens down. Minimum or maximum? Now, what this means, if it opens down, we have a height here. So this is you're going to have a max. Okay, and we'll find the vertex here in a second to know what that maximum is. Your axis of symmetry. Remember, that's going to be your opposite of b over 2a. That means the opposite of b, so the opposite of 6 over negative 3 times 2. Negative 6 over negative 3 times 2, that's a negative 6 divided by negative 6. This is going to be a negative 1. Negative 1. And the y-intercept is going to be your c term, which is 2. Now, your vertex. Oh, not a negative 1. Hold on, that's a positive 1. I hate when I do that. Positive 1, because I'm like, wait a minute, our vertex. Okay, so our vertex, when your vertex is 1, you're going to plug in, okay, so your equation, negative 3 times 1 squared plus 6 times 1 plus 2. You're solving for your y. So your vertex is 1, but we got to solve for y. 1 squared is 1, so that's going to be a negative 3. 6 times 1 is 6 plus 2. Negative 3 plus 6 is 3 plus 2, that's 5. Let's make sure that's right. Vertex is 1, 5. Now, to draw it, this is going to be not going to have a whole lot of room. Now, it's opening down. So it's opening down. Now, I'm just going to do a sketch. And the vertex is 1, 5. That means, like, that top is going to be 1, 5. The axis of symmetry. The axis of symmetry is going to go through your x value. So this is your AOS. This is the peak in which the object or whatever it is turning. Okay, that's important. You got to know how high it reaches before it starts to fall. Okay, anything else that I have to do? Well, you really should have arrows in the back of this. And then sometimes we make a dotted line there, but it doesn't matter. Okay, let's try another one. G of x equals 5x squared. Notice there's no 0x and there's no c term. So if you want to write this out for a little bit until you get used to it, that's fine. Like I put 0x plus 0. You don't have to, but that kind of helps us look at what we need. Now, this is positive. So it's going to open up. So that means it has a minimum. The axis of symmetry. Remember, it's the opposite of b over 2a. I always write that, and then I plug it in my information. Ooh, opposite of b that's 0. So opposite of 0 is 0. 2 times a is 2 times 5, which this is, well, that's 0/10. So guess what? That's axis of symmetry is 0. So that axis of symmetry is going to be on, it's going to be on the coordinate grid. Now, the y-intercept. When you find x, so x equals 0. This is your x term. Axis of symmetry, that's your x term. So when you plug in 0 for x, look what happens. That's going to be 0. 0 squared times 5 is 0. So your y-intercept, well, the y-intercept is 0 here, because you're z. Your vertex is going to be 0, 0. So, and it's opening up. That's why I always have to go back and look. So what is happening here is that your parabola is opening up like this. And this is really, okay, so here's your axis of symmetry. It's 0, 0. And it's really the coordinate grid, the origin. That's really what's happening. It's going right through. Okay. All right, let's try these two. I'm going to run out of time on this video. So if you want to try those two, you can definitely try